Okay, so now let's begin with 1.3. In 1.3, we are supposed to solve the ODEs. But here we are going to be finding the general solution ourselves, and here are a few methods we are gonna use to find the set solutions. Like unlike the first exercise, there are gonna be a few problems which are not solvable by simply separating the variables. So well, let's just look at some of the formulas. So like this is the first one is of course a simple um, separation of variables. So is the second one is also similar. There's nothing much difference about it. If we solve a question like this, we're just gonna understand it like that. In this one, as you can see here, we are given with and addition over here and then this. So over here it is gonna be difficult for us to separate the variables, of course. So we are gonna take this addition term as a certain variable and then differentiate it and then further proceed. Similarly, the fourth formula is like that too. We are just gonna, if the function of a whole equation something like this is given as that, so we're gonna assume this as a variable 2 and solve it further. uh, let's just dive into the questions, and that will be much more easier to understand like that. So let's just begin with the first question, or well, here the second question. So the question, as you can see, is given as okay. So the question is given as y cube y dash is plus x of cube is equal to 0. Then we can just simply just y cube y dash, it can be written as minus x cube, and then proceeding further, this is going to be written as y cube dy by dx is equal to minus x cube. Here, as you can see, this can be solved by using simple separation of variables. So we're just going to do that. So this is going to be y cube dy is equal to minus of x cube divided not division dx, and then we're just going to integrate this. From there we're going to gain y of 4 divided by 4 is equal to minus of x of 4 divided by 4, and of course the c. Do not forget the c. So from there we can write it as y of 4 is plus x of 4 is basically equal to c. Now we have to verify whether the solution we got, this is a solution. Basically this is a solution. The solution can be in terms of c, if in terms of y, or like a different equation, but this is a solution over here. So now we have to verify whether the solution we have obtained is correct or not. In the question, as it is mentioned, we are supposed to find the general solution, so the steps, and of course we have to verify whether it is correct or not. So we have obtained the solution. Now we're gonna to verify, we are gonna differentiate it. So the verification part, x of 4 plus y of 4 is equal to c. We're gonna differentiate it, and this can be written as 4x cube plus 4y cube y dash. For c, the y over here is basically the dependent variable. So if whenever we differentiate the dependent variable, or well y in this case, we are also gonna write this y dash term. like we did not write it for x because we do not write it for x, but we need to write it for y. Okay, so 4y cube is into y dash is equal to c, not c, sorry, 0. And then this can be written as x cube. If we take the 4 common and then just bring it to the other side, we will get x cube y dash is equal to 0. And as you can see, this is the equation we had initially too. So we can say that our solution we have obtained is the correct solution for the ODE, because we obtained the same ODE after differentiating this term. So that was the second question. Let's move on to the sixth question. So in the sixth question, it is this one. So let's do this one too. Sixth. So the question is given as y dash is equal to 2 to the power, sorry, e to the power 2x minus 1 y square, and then this can be written as dy by dx is equal to e of 2x minus 1 minus 1 y square, then dy by y square, we are basically just separating variables now, is going to be equal to e to the power 2x minus 1, the whole of integration dx. Now as you can see, it is going to be quite complex if we solve it like normally, so we are gonna substitute the value over here. We are gonna take 2x minus 1 is some variable t, and then we're gonna differentiate this. So this is 2 dx is equal to dt, and then dx can be written as dt by 2. So now we are gonna put these values in the above equation. So from there we get y minus 2 dy is equal to integration of e of t dt by 2, and so the y square, I have just written it as y to the power minus 2, and then this gonna integrate it from there. So this is gonna end up as y of minus 1 is equal to half of e of t plus c, do not forget the c, and then this can be written as 1 by y, just putting in the reciprocal, is equal to 1 by 2 e of t plus c. We're gonna multiply both sides by 2, to both sides. We're doing this in order to eliminate this term. Okay, it might not be necessary in all the questions, but we are gonna do it over here. We can obtain the answer without doing that too, but we are doing it for the sake of our own convenience, so that when we do the verification we can obtain the ODE. So this can be written as now minus 2 by y is equal to e of t, because the 2 cancelled out, plus 2c. So y is going to be equal to minus 2 e of t plus 2c, and then y can be written as minus of 2 e to the power 2x minus 1 plus 2c. We're just going to put in the values over here. Okay, now to verify whether our answer is correct or not, so here's the verification. is equal to minus of 2 e to the power 2x minus 1 plus 2c. Now we're going to differentiate it. So this can be written as using the divider rule. So this can be written as minus 2. We're going to take minus 2 as constant, differentiate the lower term, and then take the term as constant and then differentiate 2, which is going to end up in a big 0, and then e to the power 2x minus 1, taking the square of the lower term. So this is how we end up with this, which is going to be equal to minus of 4e 2x minus 1 divided by e to the power 2x minus 1 plus 2c the whole square, which when we so we have reached till this much, and then this can be written as, so y dash is equal to 4 e to the power 2x minus 1 bracket minus y by 2 to the whole square. So this was our initial equation, and we're gonna put, so this can be written as 4 e to the power 2x minus 1 y square by 4, which is going to be written as y dash is equal to e to the power 2x minus 1 y square. And this, and from here we can say that our answer, from here we can conclude that the solution we obtained was indeed a solution of the ODE. So let's move on to the next question. These are so the question numbers, as you can see, question number 7 and 7, 9 and 10, they are kind of similar in the, so in the questions where you see something like this xy dash, something like this, the xy dash put together, and then there being a equation which you can't really separate using variable separable. Here in these kind of questions we are gonna take y by x as a variable, like y by x is equal to u. In the question number 7, 9 and 10 we have done that. We did not do it, we will not be doing it in the question number 11, because as you can see there is 0 on the other side and we can easily separate the variables over here. So it is not a requirement to take y by x is equal to u in here. But in question number 17, as you can see, we are again given with the x into y dash is equal to something, and this cannot be solved by variable separable or any other method as of now. So we are going to take y by x is equal to 0. So wherever you see x into y dash, your first thought, you can just let it be y by x is going to be equal to u, especially if you see x into y dash is equal to something that cannot be solved by variable separable. So let's just dive into the 7th question. So this is given as x y dash is equal to y plus 2x cube sine square y by x. So to solve this question we are gonna be putting y by x is equal to u. So from here we can say that y can be written as u into x, and when we differentiate it with respect to u, we're going to differentiate it with respect to u. So this is going to be written as q, taking u constant, we differentiate x, so and then plus taking x constant, we differentiate u, and this is how so this is, we have obtained the value of y dash. It is going to be same for like basically all the y by x questions. Y dash is equal to u plus, this is done by the product rule of differentiation. Now we are gonna just substitute the values into the equation. So these are gonna be written as x, x bracket u plus, this substituting the values over here, u dash is equal to ux plus 2x cube sine square u, and then from here we can write that ux, we're just gonna like multiply the x inside the bracket, so this is gonna be ux x square u dash is equal to ux plus 2x 2x cube sine square u. Now of course the ux gets eliminated, so this can be written as x square du by dx is equal to 2x cube sine square u. Now we are going to separate the variables and then proceed with the integration. So let me just separate the variables. The du terms will come in here, so this will be du by sine square u, the u terms are here, and this is equal to 2x cube dx by x square from here. So now we're, of course we can just cut this part out and integrate it further. Now this can be written as, so as we know the reciprocal of sine is cosec, so we can also write this as cosec square u du integration is equal to, of course after doing that, after cutting this part, we are just gonna integrate it too. So this is gonna be equal to this is gonna be equal to 2x 2 dx in the integration Now we know the integration of cosec squared is minus cot u, so we can write it as minus cot u is equal to 2x square plus c, and then x square by 2 plus c. So this can be written as minus cot u is equal to x square plus c. Okay, and then we're gonna write it in terms of u, so this gonna bring cot to the other side, so this is gonna be cot inverse minus cot inverse of x square plus c. Now putting back the values of y of u, so it can be written as y by x is equal to minus cot inverse x square plus c into x. So this is our solution. We can take this sorry, no x. So we can take this as a solution or as a solution, or we can write it in terms of y2. So it's gonna be y minus cot inverse x square plus c into x. Now we have to do the verification. So the verification, we are gonna be using this. We're basically just gonna manipulate this equation a bit and just use minus cot y by x, just bringing the cot back to its place, and is equal to x square plus c. Then we're gonna differentiate it. Differentiating it, we will be getting cosec square y by x, which is equal to can be written as so we got cosec square y by x, which we are also going to be required to, of course, differentiate the term within the bracket. So you can just write it as e by dx of y into x to the power minus 1 for the time being is equal to 2x. Now differentiating it, where is it? And then we are gonna differentiate this part using the product rule. So it can be written as cosec square y by x multiplied minus of y x to the power minus 2 plus x to the power minus 1 y dash, and this is equal to 2x. And then we're gonna send the cosec square to the other side, and when we send cosec square to the other side, it can be written as sine square. So this equation becomes minus y x to the power minus 2 plus x to the power minus 1 y dash is equal to 2x sine square y by x. As I said, cosec square has been sent to the other side, and then this can be written as x to the power minus 1 y dash is equal to x y into x minus 2 plus 2x sine square y by x. As you can see, we have reached very close to the original ODE. So what is left is to multiply the whole term, multiply x square both sides. So finally we obtain x y dash is equal to y plus 2x cube sine square y x, and this is our final solution. Well, basically we have finally verified that our general solution is correct for the said ODE. Okay, so that was the sixth question. Now proceeding further, that was the seventh question. Proceeding further, we're gonna solve the eighth question. Now for the eighth question. So the question is given as y dash is equal to y plus 4x to the power square. Now as we can see, there is an addition term given over here, so it cannot be done by variable retrieval. So we are just gonna take y plus 4x as a certain variable, as it was mentioned in the question too. It won't be in the exam, so we're just gonna take it as u, and this can be then written as, by differentiating, y dash plus 4 is equal to du by dx, which can be further written as y dash is equal to du by dx minus 4. Now substituting the values, we get the equation as du by dx minus 4 is equal to u square, which can be written as du by dx is equal to u square plus 4. Now sending the variables over there, we take the u terms over here. Du by u square plus 4 is equal to dx. Then we integrate this by a formula. This by an integrating formula, we get 1 by 2 tan inverse u by 2 is equal to x plus c. Here formula, we can just go as, taking the 1 by 2 to the other side, we get tan inverse u by 2 is equal to 2x plus 2c, and then u by 2 is equal to tan of 2x plus 2c, which is equal to ux equal to 2 tan ux plus 2x plus 2c. Putting in the value of u, we get y by x is equal to 2 tan 2x plus 2c, which can be written as, so the final answer will be y is equal to 2 tan 2x plus 2c x, and here is a general solution. So that was the solution of the 8th question. Now let's proceed to the 11th question. The 11th question is given as xy dash plus y is equal to 0. Now as I mentioned earlier, we're not going to be taking a y by x is equal to u over here, because as you can see, it can very easily be solved by just variable separable. Okay, so 11th question, which is given as, this is an IBP form question. So we are given an initial, we have been provided with an initial value over here too. So the question is xy dash plus y is equal to 0, and the initial value we have been provided with is 6. So solving this, we get xy dash is equal to minus y, which can be written as x dy by dx is equal to minus y, and then separating the variables, we get dy by y is equal to minus dx by x. Then we integrate, and the answer would be ln y plus ln y is equal to minus ln x plus c. And then in terms of y, it was gonna be e to the power minus x plus e to the power c e to the power c can be written as c1. So we are just going to take it as y is equal to e to the power minus x plus c1. Now putting in the value, putting in the initial value we have been provided with, which is y to the power 4 is y of 4 is equal to 6, and putting it in the equation we get e to the power minus 4 plus c is equal to 6. Now if we will be putting this in the calculator, e to the power minus 4, and if we put that in the calculator we get the answer to be c is equal to 5.9. And that is how we solved the 11th question. Let's just do 16th. The 16th question is again given in such a form that we are gonna need to put this addition term as a separate variable and then solve it like that. So let's just do the 16th question. So the question is given as y dash is equal to x plus y minus 2 to the power whole square. So, and the initial value we have been provided with is y of 0 is equal to 2. Now we're gonna put this whole term as a variable v. So this is gonna be x plus y minus 2 is equal to v. So 1 plus y dash is equal to v dash. From here we can also write y dash is equal to v dash minus 1. Now we are just gonna put in the equations. So this can be written as v dash minus 1 is equal to v square, which can be written as v dash is equal to u square plus 1. This can be written as dv by dx is equal to u square plus 1, then separating, so that is supposed to be v, not u. And then this is written as dv by v square plus 1 is equal to dx, and then we integrate, we get 1 by 2 tan inverse v by 1 is equal to x plus c. This formula is being used a lot throughout the chapter, so it's just good to like remember it. And then this can be further written as tan inverse v is equal to 1 by is equal to 2x plus 2c. From here v can be written as tan of 2x plus 2c. Now we're gonna put back the value of v, which is x plus y minus 2 is equal to tan 2x plus 2c, and then writing it in terms of y, we get y is equal to tan 2x plus 2c minus x plus 2. Now we're going to put in the value of the initial value, we have been provided with, putting x is equal to 0, we get tan 2 into 0 plus 2c minus 0 plus 2, which is equal to, well, 2. From here we can write tan 2c plus 2 is equal to 2, and which can be written as tan 2c is equal to 0. 2c is equal to tan inverse 0, which means c is equal to 0, as tan inverse is also 0. And this is our answer. Let's just do one last question, which is the 17th question. 17 questions as we had solved before, like the 7th question, where we are required to put y by x is equal to u in order to solve this question. So the question is given as xy dash is equal to y plus 3x4 3x to the power 4 cos square y by x. So then from here we are gonna write y by x as u, which can be written as y is equal to ux, which means y is equal to u plus x u dash. Now replacing the values, we write x u plus u dash x is equal to u x plus 3x4 cos square u. Multiplying the x inside, we get xu plus u dash x square is equal to u x plus 3x4 cos square u, and then this gets eliminated, so this can be written as u dash x square is equal to 3x4 cos square u. We cut this too, so we get du by dx is equal to 3x square cos square u, and then we separate the variables, we get du by cos square u is equal to 3x square dx, and when we integrate, well, cos square u can also be written as sec square u, which is equal to, we can integrate this part at least, so we get x cube as the, and the 3 gets eliminated of course, plus c, and sec square u, as we know, is equal to tan u is equal to x cube plus c, which means u can be written as tan inverse of x cube plus c. Putting in the value of u, we get y by x is equal to tan inverse x cube plus c. Putting it in terms of y, we get tan inverse x cube plus c x. Now putting the initial value, which is given as y of 1 is equal to 0, putting x is equal to 1, we get tan inverse 1 plus c. 1 is equal to 0, which means tan inverse 1 plus c is equal to 0, and tan inverse, as we know, tan inverse of 0 as we know is equal to 0, so 1 plus c is equal to 0, and from here we can write c is equal to -1. This is the final answer, and that would be 1.3. There are some more types of questions in this exercise, like the modeling questions, or well, the application based questions. We are gonna cover that separately. For now, this is it. Thank you.